two thermodynamic system, A and B are in thermal equilibrium with the third thermodynamic system, C, then they must be in thermal equilibrium with each other also.
Yes. This is zeroth law of thermodynamics. It relates to thermal equilibrium. That if two thermodynamic systems A and B are in separately in thermal equilibrium with the third thermodynamic system C, then they must be in thermal equilibrium with each other also. Right? Yes, 9C, join me in the second period. This change is only for today, right? Okay, so +1, let us start with the next topic, phase diagram. What is phase diagram? Phase diagram is a graph between pressure and temperature. PT graph, pressure temperature graph, that is called phase diagram. Okay, now we are going to draw it for water. We are going to draw it for water. So see, phase diagram for water. It is pressure temperature graph. Temperature is in Kelvin. Now for water, this kind of graph has been observed. Up to here, water remains in the solid form, that is ice. Here it is liquid, that is water. And after that, it becomes vapor. Gaseous state or vapor state, that is steam. So phase diagram for water, we can express all the three states of water on this graph. So phase diagram for any material is the graph between pressure and temperature otherwise. So we are drawing it for water right now. Okay. And this point where all the three states of water, they coexist, is called triple point of water. This point is called triple point of water. This is triple point of water. It is the point at which all the three states of water coexist. Water exists in ice, liquid, and steam form together. But this happens for a particular value of temperature and pressure. It happens for a particular value of temperature and pressure only. 456 mm of mercury column. Pressure is 456 mm of mercury column at this value of pressure, and temperature 273.16 Kelvin. So only at this pressure and only at this temperature, water will have its triple point. Water will coexist in all the three states together. Got it? And you already mentioned triple point of water when we defined 1 Kelvin. Does anyone remember the definition of 1 Kelvin? Statement of 1 Kelvin that we did in unit 1. बताइए 1 Kelvin की definition क्या थी? There we mentioned triple point of water. No one remembers? So 1 Kelvin is the 1,273.16th part of thermodynamic temperature of triple point of water. ये था. And you see now what is the temperature of triple point of water? That is 273.16 Kelvin. So only at this temperature, this triple point will exist. Otherwise, it will not exist, right? So just you need to see the phase diagram for water once. One more topic we are having, related topic we are having, anomalous expansion of water. Okay, let us discuss that also. Anomalous expansion of water. Anomalous expansion of water means this is something extraordinary that otherwise liquids expand on heating and contract on cooling. Okay, but For water, something different happens. At 4 degrees Celsius, the density of water becomes maximum. After that, if we cool it, then in place of contracting, it will expand. So this is called anomalous expansion of water. ठीक है, लिख लो. At 4 degrees Celsius, the density of water is maximum. At 4 degrees Celsius, the density of water is maximum. On cooling water from 4 degrees Celsius to 0 degrees Celsius, on cooling water from 4 degrees Celsius to 0 degrees Celsius, 9C, you join me in second period. This change is for today only. Okay, see the message in the group. Okay, on cooling water from 4 degrees Celsius to 0 degrees Celsius, in place of contracting, it expands. So this is called anomalous expansion of water. It should contract on cooling, but after 4 degrees Celsius, it expands on cooling. So this is something extraordinary. Otherwise, all the liquids, they will contract. All the gases, they will contract on cooling and expand on heating. But after 4 degrees Celsius, this happens in case of water, right? This happens in case of water. Now let us start with thermodynamics. Thermodynamics. Before we start with thermodynamics, we should know few terms: heat, work, internal energy. We should know these terms: heat, work, internal energy. We are already familiar with the terms heat and work, but what is internal energy? Let us see that. Internal energy. You see, inside a gas, the molecules, they possess both the energies. Kinetic energy also, they possess potential energy also. Why do they possess kinetic energy? Because they are moving continuously. The gas molecules are moving. So that's why they possess kinetic energy. Why do they possess potential energy? Because they are having intermolecular forces amongst them. So because of that, because of distance between them, they have some potential energy also. Now this kinetic energy is a function of temperature. We know from kinetic theory of gases. And internal energy is also dependent on temperature. So on account of temperature, on the account of motion of the molecules, the energy that they are having, that is called internal energy. So you can think of internal energy dependent upon temperature only. So if we heat a gas, by raising its temperature, we are increasing its internal energy. So internal energy is directly dependent upon an important factor, that is temperature. On the other hand, potential energy of the gas, it will depend upon volume mainly. Okay, but since mainly we are dealing with increase in temperature and heating of gas and all, heat and work, conversion of heat into work and vice versa. So that's why internal energy of the gas is very, very important. So internal energy is another term. You can see that is dependent upon temperature. Okay, now what is thermodynamics? Thermodynamics is a branch of physics that deals with heat, work, internal energy and interconversion of heat into work. तो जो ब्रांच ये सारी कन्वर्जन से डील करती है, इंटरनल एनर्जी से डील करती है, दैट इज कॉल्ड थर्मोडायनेमिक्स. लिखिए डेफिनेशन. थर्मोडायनेमिक्स, इट्स अ ब्रांच ऑफ फिजिक्स दैट डील्स विद it's a branch of physics that deals with heat, work and interconversion of heat and work. It's a branch of physics that deals with heat, work and interconversion of heat into work and vice versa. interconversion of heat into work and vice versa. So as I said that internal energy mainly depends upon temperature of the gas. So when we had written dq is equal to PV dt, okay, when we are not allowing the volume of the gas to increase by putting extra weights on the piston, when the volume of the gas is constant, when no expansion is taking place, when no work is being done, then this amount of energy is called internal energy, change in internal energy as well. Then we call this amount of heat internal energy, because you see it is in terms of temperature only, because at constant volume all the heat that we supply is used up in changing internal energy of the gas. So better we can call dq as dE, where E is internal energy when we are heating the gas at constant volume. Constant pressure पे हम dq को dE नहीं बोलेंगे, ठीक है, constant volume पे बोलेंगे, because in this case no work is done and all the heat supplied that is used up in changing internal energy of the gas only. Got my point? तो आगे से हम इसको यूज करेंगे dE को, ठीक है, इंटरनल एनर्जी के फॉर्म में यूज करेंगे. Then there are thermodynamic system. What is a thermodynamic system? Thermodynamics तो हो गया. What is a thermodynamic system? For example, I told you gas is a thermodynamic system. A gas enclosed in a container is a thermodynamic system, for example, right? So what is a thermodynamic system? It is a system. It is a gas. आप gas ही लिख लो इसको. It is a gas having definite value of pressure, volume, and temperature. It is a system or it is a gas having definite values of pressure, volume, and temperature. And what are pressure, volume, temperature called? I told you these are called thermodynamic variables that affect the state of a gas. Thermodynamic variables are the parameters that can affect the state of a gas. तो जो गैस को किसी भी वे से अफेक्ट कर सकते हैं, उसके ऊपर इम्पैक्ट डाल सकते हैं, those parameters are called thermodynamic variables, and the most important parameters are pressure, volume, and temperature, P, V, and T. There are three types of thermodynamic systems. There are three types of thermodynamic systems: open system, closed system, isolated system. There are three types of thermodynamic systems. There are three types of thermodynamic systems: open system, closed system, isolated system. Now, what is an open system? Suppose we are having gas enclosed in a container fitted with a piston. It is having some value of pressure, volume, and temperature. Then this is an open system. Okay, if it doesn't have a piston also, the gas is in an open container, so heat can escape out of it. Energy can also escape out of it, and it can also exchange matter with the surroundings. Okay, so open system is a thermodynamic system that can exchange both matter and energy with the surroundings. इसी के जो गैस के जो वेपर्स हैं, अगर हम इसको हीट करें तो वो सराउंडिंग्स में जा सकते हैं, बिकॉज कंटेनर इज ओपन. ठीक है, तो वो इट विल लीड टू लॉस ऑफ मैटर, और एनर्जी जो हीट है वो तो एस्केप कर ही सकती है, because the walls of container are also conducting and its top is also open. So write down what is an open system: a system that can exchange both energy and matter with the surroundings. It's a system that can exchange both matter and energy with the surroundings. That can exchange both matter and energy with the surroundings. सेकेंड है क्लोज सिस्टम. अब जैसे हमने इसको पिस्टन से क्लोज कर दिया, दिस इज अ क्लोज सिस्टम. अब ये मैटर एक्सचेंज नहीं कर सकता, वेपर्स एज सच बाहर नहीं जा सकते, बट स्टिल बिकॉज ऑफ कंडक्टिंग वॉल्स हीट कैन एस्केप, एनर्जी कैन एस्केप. सो क्लोज सिस्टम इज अ सिस्टम that can exchange energy with the surroundings but not matter. तो लिख लीजिए क्लोज सिस्टम क्या होता है? That can exchange energy but not matter with the surroundings. Closed system is a system that can exchange only energy, not matter with the surroundings. Not matter with the surroundings. Okay, clear? थर्ड है आइसोलेटेड सिस्टम. ठीक है, अब सपोज कर लो कि हम इसकी वॉल्स को भी इंसुलेट कर देंगे. इंसुलेटिंग वॉल्स वी आर यूजिंग. इस कंटेनर को इनसाइड वी अप्लाई सम थर्मोकोल और ग्लास वूल. वी इंसुलेट इट फ्रॉम ऑल द साइड्स. Now it can neither exchange energy nor matter with the surroundings. This type of system will be isolated. Okay, so when we have some insulating container, it cannot exchange energy as well as matter with the surroundings. This type of system that cannot exchange energy as well as matter with the surroundings, that is called isolated system. So लिख लीजिए isolated system. It is a system that can neither exchange energy nor matter with the surroundings. That can neither exchange energy not matter with the surroundings. Is that clear? So three types are clear to you? Okay, then we come to thermodynamic processes. अब एक प्रोसेस क्या है? ठीक है, when the गैस को हम वर्किंग सब्सटेंस भी बोलते हैं. ठीक है, when the system is undergoing a series of changes, that process, that procedure is called a thermodynamic process. ठीक है, वो तो आपको पता ही है. Now let us discuss the types of thermodynamic processes. There are 4 types of thermodynamic processes. There are 4 types of thermodynamic processes. First is isothermal process, adiabatic process, isochoric and isobaric. There are 4 types of thermodynamic processes: isothermal process, adiabatic process, isochoric process, and isobaric process. Most important are the first 2. Now, what is an isothermal process? It's a thermodynamic process in which temperature doesn't change. Temperature remains constant. So that means delta T is 0. It's a thermodynamic process in which temperature remains constant. Temperature doesn't change. Okay? Isothermal process is a thermodynamic process in which temperature remains constant. Can you give any example where temperature remains constant? Can you give any example of any thermodynamic process that you have seen in daily life where temperature doesn't change? अरे कल हमने किया ना latent heat का. So melting of ice is an isothermal process. उसमें temperature change नहीं होता, state change होती है ना? So you can write melting of ice. That is an example of isothermal process. Okay, then we come to adiabatic process. First, let us discuss isothermal process in a bit of detail. For carrying out an isothermal process, there are two conditions required. Okay, for carrying out an isothermal process, there are two conditions required. Okay, suppose we have gas enclosed in a container fitted with a piston. Then first condition is that the walls of the container must be conducting. Walls of container must be conducting. This is first condition for carrying out an isothermal process. Now what is the reason? क्योंकि suppose कर लो कि we press the piston, we compress the gas by pressing the piston inwards. We compress the gas. During compression, temperature of the gas raises. Gas heat up हो जाएगी. ठीक है? If the walls are conducting, the base of the container is conducting, that extra heat gained will escape into the surroundings. So we allow the exchange of gases in this case. Okay, we allow the exchange of energy in this case so that after some time temperature becomes constant. If we won't allow the exchange of gases, then when we will press the piston, the gas temperature will raise because of compression, and when we will release the piston outward, then due to expansion of the gas will cool, its temperature will fall down, it will no more be constant. So we should have conducting base and walls of container to have isothermal process. Second condition, these processes, the compression of the gas, expansion of the gas, must be carried out very slowly so that we give time for heat exchange. We allow heat exchange. These processes must be carried out very slowly. Which processes? Expansion or compression of the gas. Expansion or compression of the gas must be carried out very slowly to allow the time for exchange of heat. Okay, when we compress the gas, so we should do it very slowly so that the extra temperature, extra heat goes into the surrounding side by side and temperature becomes constant. And when we pull the piston outwards, the gas cools, then we should allow the extra heat to enter from the surroundings. अगर surroundings high temperature पे हैं, अंदर temperature कम हो गया, conducting conditions हैं और slow आप उसको carry out कर रहे हो, तो उतनी heat बाहर से आ जाएगी and again the temperature will become constant. So this is how we can achieve isothermal processes. So there should be two conditions and you should be able to explain the conditions. Why conducting? So that there is proper time for heat exchange, and why it should be carried out slowly, so that there is, again we are allowing time for exchange of heat during compression or expansion of the gas. Any doubt? Yahan tak koi doubt? Yes, students, any doubt if you have, you can ask. Chaliye, very good. Next है adiabatic process. We used this term, we used this word yesterday. कहाँ पे use किया था? याद है किसी को? बताइए. Where did we use this word adiabatic? कल ही use किया हमने. Who will tell me? Zeroth law of thermodynamics में हमने A और B systems के बीच में adiabatic wall लिखी थी. वहां लिखा था ना? So I told you adiabatic means insulating. Okay, it means insulating. चलिए, तो adiabatic process क्या है? It is a thermodynamic process in which exchange of heat is not allowed. Delta Q is 0. Exchange of heat is not allowed, but temperature may change. Temperature change allowed है. Isothermal में temperature change allowed नहीं था, heat exchange allowed था. In adiabatic process, no exchange of heat is allowed. Temperature may change. Temperature may change. इसका एक prominent example note करिए. Propagation of sound through air is an adiabatic process. When sound propagates through the air, this is an adiabatic process. Propagation of sound through the air is an adiabatic process. Okay, so heat exchange is not allowed. So what are two conditions for achieving a process adiabatically? कैसे हम ये करें कि heat exchange allow ही ना हो? So there are two conditions required for that. First तो यही है कि container must be insulating from all the sides. ये piston भी हमारा insulated है, ये walls of container भी insulated होनी चाहिए, so that we are not giving any time for exchange of heat. हम heat escape ही नहीं करवाना चाहते, ठीक है? तो first condition is insulating walls and base of the container, ठीक है? Insulating conditions. अगर हम हीट कर रहे हैं तो बेस को आपको इंसुलेट करना मुश्किल हो जाएगा, तो आप अकेला वॉल्स तक ही लिखिए. इंसुलेटिंग वॉल्स एंड पिस्टन. इंसुलेटिंग वॉल्स एंड पिस्टन of the container in which gas is enclosed. Second है the processes of expansion and compression must be carried out very fast. ये processes बहुत fast carry out करने चाहिए हमें, ठीक है? क्या होगा, हमने जैसे we pressed the piston downwards, the gas is compressed, its temperature raises, and we should do it very fast so that there is no time for heat exchange. We don't want the heat to escape now in this case. We don't want the temperature to be constant here. So during compression, the temperature should increase. During expansion, the temperature should decrease. So that there is no chance of exchange of heat. That's why we are carrying out these processes very fast. The expansion and compression of the gas should be carried out very, very fast because of this reason. Is that clear? यहां तक कोई डाउट? क्योंकि ये डिटेल में आपको पता होना चाहिए आइसोथर्मल एडियाबैटिक प्रोसेस. आपको ये क्वेश्चन भी आ सकता है कि व्हाट आर द कंडीशंस फॉर आइसोथर्मल प्रोसेस, व्हाट आर द कंडीशंस फॉर एडियाबैटिक प्रोसेस. चलिए अब आते हैं थर्ड प्रोसेस पे, आइसोकोरिक प्रोसेस. इट्स अ प्रोसेस इन विच वॉल्यूम रिमेन्स कांस्टेंट. अ प्रोसेस इन विच वॉल्यूम रिमेन्स कांस्टेंट. And isobaric means in which pressure remains constant. Isobaric process in which pressure remains constant. For example, isobaric का example है boiling of water. You know, when the inside pressure becomes equal to outside pressure, then the boiling point occurs. Then the boiling takes place. So boiling process, you can say, is an isobaric process. It happens at constant pressure. For example, when you go on hilly area, what happens? Because of change, because of decrease in outside pressure, the boiling point of water is also altered. Boiling point of water also changes. वहां पे water किसी और temperature पे boil होता है. यहाँ हमारे plains level पे 100 डिग्री सेल्सियस पे water boil होता है ना, height पे water का boil होने का temperature भी different हो जाता है because of change in pressure. Okay? The boiling process becomes or exists or occurs when pressure, inside pressure of the system and outside pressure, they become constant. So this is an isobaric process, you can say. ठीक है स्टूडेंट्स, देख लीजिए कोई डाउट आज के लेक्चर में से. अगर आपको कोई डाउट है तो पूछ सकते हो. हैव अ लुक. ज्यादा थ्योरेटिकली था आज का, ठीक है?